pardon me, we don't have a lady yet in the virtual room. But even as we anticipate a lady joining, or ladies joining. So, and it is with a great pleasure I introduce our guest LP lecturer for today, who is no other person but Engineer James Omeke. He is a research and development engineer with Total Energies in France. He is a performance-driven reservoir engineer and data scientist with extensive experience in business analytics and utilization towards driving investment optimization, risk reduction, and cost cutting to production. He from the Federal University of Technology, where he obtained his Bachelor of Engineering in 2007. He went further to run a postgraduate program in artificial intelligence and machine learning in the year 2020 from the Red McCombs School of Business of the University of Texas at Austin. Now, moving forward, he obtained a master's degree in reservoir geoscience and engineering from the IFB school in the year 2021. Now, Engineer James had his early career as an operations and logistics intern with the Anotech Global Company Nigeria Limited from 2008 until 2009. He has taken the role of a reservoir engineer with Laser Engineering and Resources Consultants Limited for 2 years. Pioneer Alpha Petroleum Service PPS for 3 months and Limited for 1 year and 8 months. He has a 5-year experience serving in the role of a reservoir engineer and later on a senior reservoir engineer with New Cross E&P since 2016 until early 2021. And currently, he is a research and development engineer with Total Energies France. Now, Engineer James has earned so many certifications and awards as a product of his professional thrive through the oil and gas industry. Amongst them is he's been amongst the winners of the 2019 NIE's Young Professionals Robotics, Artificial Intelligence, and Data Science competition publications, and most recent of which is well performance optimization using experimental design approach. Ladies and gentlemen, our guest speaker for today speaks Igbo as from his name, James Omeke. He speaks Igbo as a native language. Now with a virtual clap, if you permit me, help me welcome our guest LP lecturer in person of Engineer James Omeke. Engineer James.
Hi, can you all hear me?
Yes, we can.
Yeah.
Yes, we can, sir.
Okay. I know the network issues are sometimes severe. So while you are making some comments, it was sometimes we miss it and then we get it back, but we understand it's what it usually is. So I am glad to be here, to be invited to this occasion. It's something I hardly say no to, especially when I get this call from young minds. So I quickly decided to prepare something to show us today, and then we can also discuss. I believe we all have our phones or our, because there are some things we are going to be looking at where you might need to log in, and then we do some quick polls and gather some opinions. So let me share my slide. Okay, I'll share my entire screen so that it's easier for me to share my slide. Yeah. Okay. Can you see my screen?
Yes, we can, sir. Yes, we can.
Good. Okay.
But maybe you put it on screen share. Okay, yeah, it's up now.
Yes. So this is what we're going to be discussing today. I would like to start by going through the content of what those possible things we are going to see today. Just for a start, we'll just show a quick video, just a 4-minute video about what the digitalization and the industrial revolutions, how things have changed over time, from the first industrial revolution to the second, to the third, and to the fourth. Okay, so we'll move on there to do some quick polls and gather some opinion from you guys. I will share, when I get to that part, I will give you some specific instructions. And then we will look at the digitalization and energy trend. And then from there, we can move on. Okay, so let me go to the next slide. I don't know if you all are hearing me clearly and you can see my screen. I want to be sure that if I am off, please, you can use the chat window to always send your messages and comments. Okay. So
yeah, that's fine, sir.
Yes. So I'm going to play this video for us to listen. Let me start. I know you might not have the required bandwidth, but in case it freezes, don't worry, I will explain. It's just a short video. Can you hear the sound?
Yeah.
Okay, good,
sure.
Good. I want to be sure that the sound is there because and then not too loud, yeah, 33%. So.
When technology changes, the world changes with it. History has been witness to industrial revolutions that have taken place over the ages. The first revolution, triggered by steam power, proved that manpower is not the only way to progress.
So I will be pausing in some sections and explain. I know some of us are familiar with this, the fact that we moved from manpower use. And usually before the first industrial revolution, everything is done by hand. But the first industrial revolution ushered in the steam, they call it the steam era, where steam energy is used to drive process.
Machines joined muscle and reduced human effort. The second industrial revolution brought the world together with electric power. Leaps in technology paved the way to a new way of life and a global economy. Then, the computer changed everything. Information technology and electronics led the third industrial revolution. Workplaces became smarter, technology got personal, and communication went mobile. The fourth industrial revolution is bringing together physical and digital worlds across industries to create an interconnected global value chain. Powerful technology, incredible connectivity, and unlimited information is available at your fingertips. Breakthroughs like machine learning, artificial intelligence, augmented reality, blockchain, robotics, and Internet of Things are rapidly changing the way we live our lives. The consumer is at the center of a connected ecosystem that delivers personalized needs at any time of choice. Business leaders across the world are gearing up to be a part of this ecosystem and be omnipresent for their consumers. New players enter and disrupt the game every day while constantly changing the rules. Organizations must change the way they work and strategize while adapting to the new world. It's time to leverage emerging technologies and seek collaborative opportunities to provide new and personalized experiences for everyone. Digitalization brings the world closer by erasing physical boundaries and breaking limits. It's important to keep up with the demands of a transforming world that seeks access to incredible opportunities in the most intimate of environments. Are you ready to lead the fourth industrial revolution? Welcome to Suntech Conference.
Okay, so the question is, are you ready to lead the fourth industrial revolution? We are in the fourth industrial revolution already. And this is where we are today. And that is why this topic is coming up. The challenge of digitalization, how it is influencing the energy sector. These are part of what we are going to be looking at today. So, but quickly, before I go into the main business of the day, I want to get some quick polls and opinion from you guys. So if you are with your phone, I want to share this link. If you can, let me see if I can paste it here so that it will be easier for you guys to copy. If you go to the chat, you will see I put a link there, www.slido.com. If you type in that link, it will lead you to the Slido page where it will ask for a code. Then when it asks for the code, just put in this first code, 676639. You can use your phone. If you log in with your code, just let me know, maybe by indicating in the chat box or in any form. Okay, please, quickly. If you are in, you let me know. And I will go to this link. So, are you guys with me?
We are, sir. Yes.
Okay. Okay. If you've logged in with the code, let me know.
Okay, I think for better understanding, I think we're using a different browser, or we are logging in here so that others too can follow.
Yeah, so you can use your phone, just your own your own general phone is actually okay. Is actually a multi-choice activity. You are going to choose from some opinion, and then we'll see the outcome based on joint opinion. So it's simple. Once you go to www.slido.com, you log in, and then we'll I will start up. When I start up a question, you will see it on your phone screen, and then you make your choice. Okay. And then in real time, you will see the result. I think some of us are logged in because I can see some of your messages. So I'm going to start because of time. I'm going to start now. So look at your screen, your phone screen, if you are logged in. So you make your choice. So the first question is, what aspect of the following digital technology would catch your interest in the future? So I've listed some digital technology. Remember, once you make a choice, try to click the submit button when you scroll down. So if you make a choice, well, I have options here. So you choose which you think. So I have 3 persons now. I have 3 answers. Any more answer? I have 5 answers. Any more answer? 6. Okay. Okay, I think I don't think we are much. Okay, so if you can see my screen, on real-time basis, you will notice that the artificial intelligence, let me make it more obvious so that we'll see it bigger. A lot of you went for artificial intelligence and machine learning, and then we have few people for big data and industrial Internet of Things, and then we have augmented reality, and then we have digital printing or 3D printing. But from here, we found out that, well, most of us are interested in artificial intelligence and machine learning. Good. I just want to get the feel of everybody in this class. Okay, I'll go to the next question. I'll close this. When I click the next question, it's going to appear on your screen. Okay, so the next question is, to what extent have you improved your knowledge about insight using data? So you are going to choose between 1 and 1 is the lowest, 5 is the highest. And we'll see if we are making progress based on our learning. I have 2 votes so far. I have 3 votes. I have 4 votes. And I have 5 votes. And yes, and I have the 6th vote. Okay, so we've tried, but we are not there yet. Okay, that is nice. Good try. Most of us are in the middle. We are trying to improve our knowledge, but we are in the middle. Some are in the 4th place already. That is okay. It's very generally understanding. In fact, this is the trend that we usually have when you look at the learning. But we are not yet there, but we'll be there very soon. Okay, that is a good improvement. Let's go to the next question. The next question is a multiple choice question. It says, do you feel that you fully understand the current digital transformation? So just give your honest opinion. Do you really understand? Do you really, do you feel that you fully understand the digital transformation today? Okay. Okay. 50-50. Okay. Okay, 50-50. Okay, so some are saying, yes, I fully understand, and some are saying, not really fully understood. Perfect, perfect, it's expected. Yeah, in a class like this, we don't expect everybody to be champion or to understand everything. But that is fair enough. So this is the end of the first part of it. We're going to go to the second part of it. If you go back to your, let me go back to my screen. The second part of it, there is this button here. If you can look at my screen, that is button here where you can click and you see switch event. Switch event. If you click that button, just click on switch event. It will switch to this second. It will switch to another page where you put in this second code, 360298. 360298. I will paste it in the comment section quickly. That is this for the second one. If you are logged in, I believe you guys are logged in. Let me go back to the web page for the second event. Okay, I'll go back to event. Okay, so if you are logged in, I'm going to start with the first question. Okay, good. Okay. Okay. Can you see the question? Is it, what educational sites do you usually visit to learn data analytics? I think it's when you type in something there, and we are going to see the results here. We're going to see Just type, not the link, not www. Just for example, I know of GitHub, and so are you there? Okay, so the code is 360298. Let me stop it. The code is 360298. Hassan Book, you are in already. Okay, Abednego is asking for the code. Okay. Let's do this quick because of time. Okay, I assume that we all are logged in. 6 of us that have been answering before. Just send me, just let me know through the chat. Okay, so I'm going to start again. So what educational site do you usually visit to learn data analytics? I have one answer, Quora. Any other answer? I know Quora is a good site. Or don't we go online to study data science or data analytics? Or is it that it's only one person that is logged in? Okay, so I see someone say, is Alison, is it one of this, is it a site to visit? Okay, if I don't know about that. Okay, we will have only one answer for now, possibly. So, but for me, I use Coursera, I have Edwonix, I have Udemy, and of course Quora. Okay, because of time, I'll move on. So for this, you make a choice. Do you usually finish and understand most courses you do online to boost your knowledge about data? Do you usually finish? Somebody said no. Two people, no. It's funny, right? I thought I was the only one that is having this problem. Sorry. Okay. Anyway, when I started learning data science, it was difficult for me to finish anything online. But recently, I was able to finish most of the ones I didn't finish before. So sometimes it's like that. It gets boring, especially when you don't visit. When you don't understand, it gets so bored and you go off. Okay. So it's 3% usually don't finish. Please try and finish up the ones you've left. Okay, I'll go to the next question, which will be the final one. So it says, how would you rate your understanding of the digital trend in energy? So how do you rate your understanding? Do you have a very high understanding, very intermediate, or low? Just give us an idea. Okay, honest opinion, very good. We're between 1 to 3, which is okay. It's okay. Yeah, 3. Perfect. So this is very okay for us, at least for a start. We are at the mid-level, which is okay, mid-understanding, which is fine, of course. You might not get to know everything now, but you will, with time, you will definitely get to know it. Okay, I'm going to go back to my slide because this honest opinion has really helped me understand how to really address this issue. Okay, I want to play a short video again. Sorry, I think this will be the last video I'm going to play. So this video is just a big picture about the digital transformation and digitalization in the energy industry. So just listen to it. It's about 1 minute. So these are the capabilities that we could derive from digitalization. We have the robotics, we have the improved productivity due to digitalization. We have the renewables, we have the solar. Even in the oil industry, we have increase in production. And then, we have growing demand. And also we have huge connectivity, smart grid systems. All these are enabled by digital transformation. And then, of course, it comes with its own risk, but it's very necessary for the improvement of industrialization processes. Okay, so this is a very good resource for you to find most of the information about digitalization, the IEA.org. And I'll be showing us some of the trend in the industry, in the energy sector going forward. Okay, so this next slide tells us how the robotics have actually influenced different sectors of the industry. And we can see that the highest influence in robotics is in the automotive industry, the car industry. So you find out that we have a big influence of robotics at the end of 2015, which is the green, and then at the end of 2013. So if you look at the trend, we have the automotive industry at the top, followed by the electrical and electronic industry, the metal industry, the chemical, the food, others, and unspecified. I didn't see the oil and gas industry here, of course, because I think most of the activities in the oil and gas industry is still at, in terms of robotic use, is still at the preliminary stage. I don't think there are much, although there are some projects ongoing that will enable the deployment of robots into some deep offshore operations, but possibly they might be among the others. But the major key point I want to point out in this slide is that robotics is part of digitalization, and it has influenced so much all aspects of the industry with huge impact in the automotive industry, okay? This next slide deals with 3D printing. I don't know if we're familiar with 3D printing, but if it's usually a way of creating materials, right? Using printing, using 3-dimensional printing. So we have machines for that. And if you look at this slide actually shows the potential reduction in metal demand in the United States in terms of use in commercial aircraft. If you look at this slide, we have this slide portrays the fact that a lot of materials has been reduced due to the use of 3D printing. 3D printing allows you to, allows a company to make use of specialized materials that are lightweight, that are not necessarily the steel, the aluminum, the alloys, but lightweight material are used to create product. And this is very, very useful in the aircraft industry because since we are in the era of CO2 reduction, the drive has always been to reduce the emission of CO2 or the fuel consumption. And if you use light materials, you reduce that fuel consumption. So if you look at this slide here, it shows the trend, what is going to be like. So if there is a rapid adoption, there's going to be high reduction in the use of materials. So a comment here says that the assessment found that 9% to 70% of total typical aircraft mass could be replaced by a light 3D printing component in the near term. If fully adopted in 2050, this could avoid nearly 20,000 tons per year of metal demand and reduce the overall fuel use of the US aircraft fleet by up to 6.4%. So you see this 3D printing technology. We even see that I have been in a program where it is actually proposed for the use for the development of drill bit. Yeah, drill bit for drilling. So we have every different applications of this. And the next slide here is about the potential impact of digitalization on global technical recoverable oil and gas resource. This one, we are very familiar with it. When artificial intelligence and machine learning came on board, there was a rapid increase in the in-depth knowledge of what is happening on subsurface using data. So if you look at this chart, this part of the quadrant, it shows you the conventional assets. So the dark blue part is the potential impact of digitalization. So in the conventional area, we found out that there is not much because we have a lot of old fields that are depleted. And then most times what is really needed for such fields are EOR processes. But for the unconventionals, which are yet to be fully understood, we have this rapid improvement using data analytics, especially in shale gas or shale oil. And then you see the impact of digitalization on this unconventional. So these are metrics gathered from IEA reports. You can always see them online. And this one is worldwide cost saving from enhanced digitalization in power plant and electric network. So you see what digitalization is doing. This is 2016 chart. Now, due to digitalization, there is 5% lower operation and management cost. Of course, because when you have a fully digital process in place, you can actually identify root causes. You can actually be proactive in identifying the problems and be able to sort it out. And then they will have 5% more electrical output per unit of fuel. And then we also have a very huge extension of power plants, because if you look at the power plants, one of the major challenges we have in operating power plants in power sector is the fact that they fail. So preventive maintenance powered by proactive predictions of failure has actually improved the life extension, the life span of power plants, and also 5 years life extension for network. So I'm just giving us the digital trends and how it is influencing the energy sector. Now, this is back to sub-Saharan Africa. This is how digitalization is going to influence power, especially in sub-Saharan Africa. Yes, if you look at this light blue is actually the mobile phone owners in rural households. So we have huge amount of people having mobile phone, but very small rural electrification. So we have less power when we have more phones. So what power are we going to use to be charging the phones? So if you look at it, Nigeria is here. We have Ghana here. If you look at Ghana, you see they have this is the amount of mobile phone they use, and then you see there is somehow a commensurate amount of power, although not fully equal, that is available to power the phone. Assuming you don't have mobile phone, then you won't have power. So what does this chart tells us? Because of the abundance of mobile phones and internet, which is digitalization, it is now forcing power to be generated. It's now forcing rural electrification, because in the rural regions or in the developing countries, it is the use of mobile phone that is influencing the availability of power. But you can see in Nigeria, we are still far off, okay? Ghana and Kenya is ahead of us. So we have more mobile phones, but yet we don't have power to use in powering it. But it's okay. It's good that most of us here are able to charge our phones to be able to attend this meeting. Okay. Now I want to show us some things about career transition and how digital opportunity has actually brought about career transition. I got an email from the Way Ahead from SPE, where these two ladies were discussing on how they actually transitioned from oil and gas to something digital. but still in the oil and gas sector. So Nefeli told us her own story, and then Joe Wetton told us her own story. The link is here. I have a link here, but I won't go there because of time. So what happened was that she was initially a reservoir engineer, but has joined NVIDIA company as a graphic tech company. Now he joined in the NVIDIA as a subsurface engineer. He's still not out of the oil and gas sector, because NVIDIA, yes, they are not known for oil and gas services, but are known for GPUs. So, but she joined NVIDIA because NVIDIA has interests also. They provide oil and gas services possibly by making our softwares and our GPUs faster in processing devices and in processing information. And if you look at NVIDIA, they are championing the GPU architecture. So that is the graphical processing unit. So what she did was to join them during the pandemic, when there was really nothing in the oil and gas sector, when there is no job. So she saw that opportunity and grabbed it. And today she's doing very well, supporting subsurface reservoir engineering and simulation jobs using an NVIDIA from NVIDIA industry. Similarly, for the lady down here, she was a geologist, and then she turned into a UX designer. More like user interface or software product design. That is what she does in Halliburton. So these are opportunities. So when I say opportunities, when you don't have that opportunity fully in the oil and gas industry, if you look at the oil and gas industry today, that we lack this flexibility in terms of digitalization, even though there are some companies here in Europe and all over the world that are really taking this up. And it is glaring that this is what everybody has to go into. So companies like Equinor, Total, Shell, and many more are now cultivating this habit of bringing in strong digitalization processes, even though we have some existing ones, but we need to take them to the next level. And that is why we have a lot of open source softwares today that could help drive digitalization. So, but we see other companies, the tech companies that are already into it, the Facebook, the Amazon, the NVIDIAs and co, they're already in it. And you also see some of these companies also partnering with the oil and gas companies to provide services. So with this, we are creating larger amounts of jobs for those that have that skills. So it's an encouragement for every one of us to try as much as possible to acquire that skills. Maybe we'll see how to address that during the question and answer section. And then if you have time, you should watch the video about the role of young professionals in the energy transition. It's a very good video. I will share the links much later. Let's move on. Okay, so before I go into what I want to present shortly, maybe the application, I want to quickly also show us this slide, how digital transformation is actually impacting the oil industry. Just like I gather from your poll, I saw a lot of you are interested in artificial intelligence and machine learning. Of course, it is the heart of this whole process. It is really the heart of this whole process because we deal with data. So we have two forms of data, the big data and the Internet of Things. The big data have these following characteristics. We have large volumes. They are delivered at very high. They are delivered at a very high frequency. So you have a very high velocity. There are the variety of them from different sources, and then they are also veracity. So in other words, most times they don't correlate with each other. So every data source has its own independent information. Similarly, the Internet of Things is where you see sensor technology and automation, which we can actually find in some of our fields today, where you have clamp-on sensors, the flow stations and the wellhead that deliver information on real-time basis. But for us to be able to understand these informations, we need to use data analytics and machine learning to understand, gather insight, and then these insights we gathered can actually change the business process. So we have these processes in place that can actually change our business model, the way we think. So it revolutionized it, and these are the outcomes that we could derive from this. We could create new digital platform for customers interaction. We could update revenue, improve operations performance, and give players greater choice and independence. Okay, so in my next slide, I'm going to quickly, because of time, present what we did as a contribution, as our own contribution to digitalization. So I and my team, we participated in a competition organized by DOPS drilling data competition, DOPS, yeah, they will call them. Let me go to this. I will go to the site and show you. But I did this job with these four guys. I led the team, and we did something on drilling automation. We try as much as possible to see how to automate the process of identifying bad sensor data from real-time sensors. Okay, so our work, our project, our research, I'll call it all that, actually won the best award. If I click this link, it will take us directly to the site. Yeah, you see. So this is DUPTS, Drilling Uncertainty Prediction Technical Section. And it's an SPE competition, students competition. And if you look at it here, we are here. The IFP school, we did this earlier this year. We came first. And then the Kemfad University, I think Kemfad University in Saudi Arabia also came second. And then the guys in Argentina came third. So I'm really proud to show you guys that that we can make this impact and contribution. So I'm going to take you through what we did, a little bit of advanced artificial intelligence, but then I just want you guys to have the feel. Okay, I'll leave this. I'm going to go to the next slide. So what we try to do is the fact that we have this challenge of huge amount of data coming from sensor. In fact, sometimes you can't use Excel sheet to collect this data because, for example, Excel sheet is limited to about 1.4 million rows, if I'm not mistaken. Now, but you have something coming in per second basis, which when you load in Excel, you can't even contain it. So that's why most times, if you see this sensor data coming from drilling rigs, they are usually stored in an XML format. XML format allows you to store huge amounts of information. So imagine one of the biggest challenges we have is that these sensors, they always release very bad, some of them, especially the ones that are not calibrated, they actually release very bad data, some of them. And most times we don't really want to go and calibrate them. There is this reluctance in calibrating these sensors because if it is deep offshore, for example, you might not want to start going in and out and changing sensors here and there. But what matters is the information that you get from the sensors. How do you best make use of it, especially the clean ones? So as humans, if you try to do that yourself, imagine getting data in per seconds, and then you have up to 20 gig of data coming in one day, and then you have the next day. You have the next, and then you have up to 30 days of drilling, and each day you're getting up to 20 gig. Then how do you identify the problem? Well, you have such huge amounts of information. This is where artificial intelligence came in. So our work here is to try as much as possible not to avoid the use of manpower efforts trying to fix ranges, and if you look at this particular part, this guy is trying to put range, like, okay, any data that is between this range, maybe, for example, weight on bit, if it is between 300 to 500, anything below 500 and anything above 300 is not correct. So putting those kind of range are not really excellent because it limits you have this kind of limitation where you just have a channel here. You have this green channel where you have only good data. So outside this part, you have every data is bad, you see. So that is not what we want. We don't want a situation where, because this kind of data you get scattered this way, and in this data scattered, you have the ones that are good and the ones that are bad. You don't need to use all the information, because if you use both the wrong and the right sensor data together, you're going to get wrong predictions. So how do you automatically identify wrong data, bad data, without using so much of human effort, knowing fully well that you are going to be getting huge amount of information coming from your drilling sensor? So that is the objective of our project. And then what we did was, okay, we said this concept will be better for us. Let's make it this way. Let's drop a concept, because one thing about data science and the application of artificial intelligence is that you need to have a concept, a thought process, not really jump into the code, even though the code is good, but you have to have a thought process. So our thought process is that, okay, we're going to get this data directly from the rig coming, on real time. We're going to develop a database where this data is going to be stored. And then this database will transform the data, because, like I said, the data is not coming in a very good format. It's coming in an XML format. XML format is like web format, so you might not be able to work on it directly. It's unstructured, as we call it. So we convert it into a database of data that can be used. For example, CSV, XLL, Excel format, or all that. And then you use an you program an artificial intelligence that will read this data and output the same amount of data, but flagging the data that are wrong and the ones that are right automatically. For example, let's assume that this line here we are having here, these arrows are passing through the good data, and then these other data are the wrong data. So something like that. And then at the end of the day, the engineer will just sit down to see the result, which is good and which is bad. And then he can judge it based on his own experience. You see this concept? Very okay. So where the major work is this cycle, this square we have here, where you transform the information from the database to AI model and then to visualization for use. Okay, so that is our concept. The next thing is that we explore the data. So yes, so what we did was that, look at how, okay, this is an example of how the XML format is. For example, if you look at this, you won't be able to extract anything here, okay? On the way it is, you can actually read them. But if you look at this critically, you see I have ROP here, I have weight on beat here, I have WOP, and different kind of information. Yeah, but I don't want to work with it this way. I want to process it. So my colleagues, some of my colleagues that are good in front-end, back-end development, I asked them to help me with a quick analysis of this data. So we use a Node.js, JavaScript, and Node.js software to develop and process the data in a format that we can use in Python. So what we did was to transform the data into an Excel CSV format, and then we use Python to do the remaining analysis. So these are the data we got, and they are all in tabular form. So we have the bit depth, weight on bit, block position. These are information, this list of informations here you have here are actually delivered from sensors. So we have a bit depth sensor, weight on bit sensor, block position sensor, average rotary speed sensor, and all that. And these sensors are also affected by heat, they are affected by temperature, they are affected by depth, drifting and all that. So regardless of the fact that they are going to be delivering large amounts of data, we are going to have a lot of data in those sensors that are going to be bad, and we're also going to have the ones that are going to be good. So being able to leverage on the good one, we'll be able to do our performance forecast and analysis better. So this is the final form of our process data. So we've moved from XML, where we cannot use this, and then we'll transform it to CSV, and then we can also visualize it. You see how it is? Very, 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 very dynamic and temporal. So if you look at it, you see how scattered it is. At a given data point, you can have at a given time, you can have huge, huge transients of information, And then inside this information lies the good ones and the bad ones, okay? So I'll go to the next slide, and we're able to process about 2 million rows of data that we used to, so what we want to do is to identify bad and good sensor data inside these 2 million rows. What would be the good data? What would the good data be used for? To be used for machine learning. The bad ones will be flagged off, okay? So that you have a better prediction. So we also did exploratory data analysis to see how the data varies with whole sections. I won't go into details about this. Just to tell you, this is just to give you a feel of how we apply it. But then what I wanted to know is that the major thing I'm trying to get in here is to allow ourselves to understand what we are dealing with, because understanding the data trend is very important. For example, if I move from 36-inch whole section to 17-inch whole section, I don't get the same distribution I get here. Look at the distribution, everything is changing. So here, DBTM, we have a kind of unimodal, but here you see a kind of bimodal distribution. This is like a cumulative frequency distribution. And the same thing you see here. Here you have this large distribution, and here you have it very skewed. And then you see it change again in another whole section, 12.25-inch whole section. This same distribution here is changing. So what does that mean? It means that I won't limit my training data on this whole section, because if I limit my training data in this whole section, 36-inch whole section, that means I'm going to forgo, if I run a prediction, I'm not going to capture this behavior. So that is what this told us. And then we decided to use the entire whole section data to build our model, okay? So that is the importance of exploratory data analysis in machine learning. And also we try to understand if these data are truly independent or they depend on each other. For example, if you can predict weight on bit using hook load, then that means both of them are dependent. So we want to know if they are truly independent, because in machine learning, you deal with independent variables and dependent variables. So if your independent variables are not truly independent, then that means it's not going to give you something good, okay? That is why we have something like multi-collinearity problems in machine learning. Those are the advances in machine learning. These are the things that you need to check. And then if you are okay, you can move on. So important, very, very important is exploratory data analysis to understand it. And that is where some bit of statistics come in. So you need to get that statistical knowledge, even if it is not very deep. I didn't go through the whole entire statistics to be able to understand what to do with data science, but they have some specific area of statistics that they want you to know. And then you have your linear algebra to also play with. Now, the challenge we have is that, yes, we have data. So what kind of artificial intelligence? We have a lot of them. What kind of artificial intelligence model you want to use? In machine learning, we have a lot. We have different algorithms. So this is why sometimes you need to understand algorithms. So in our own case, we have to go through different algorithms to know the one that is best suited for us. So, but what we did is that we narrowed down to algorithm that handles time series data and algorithm that handles classification. In other words, the algorithm that can tell you that this data is wrong and this data is right, things like that. At least that will narrow it. So we're dealing with a classification problem, right? So we're going to be talking about what is good and what is bad. And then we looked at what handles very, 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 very complex data like we have in our data trend. If you look at our data trend that I showed you, it's very, very, very complex. You see? Very, very, very. Now, so we have these algorithms, very powerful algorithms, which I am also exploring them for other use, especially in static modeling, property modeling in static form. The DB-scan, LDB-scan, and STB-DB-scan. These are very, very strong algorithms, but they are all density-based algorithms. I won't go deep into them, but the disadvantage of me not using them is the fact that they cannot capture temporal dependencies properties across different time steps. For example, at a given time step, you have a characteristics of the data, how the data behave. But when you go to another time step, the data behave totally different. So some of these algorithms sometimes doesn't capture these changes in behavior of data at different time steps because they are density based, okay? And then the Bayesian belief network, very good network. You use that to tell if something is going to occur or not. is using you use joint probability distribution to make inference on an event. Of course, it's good because you can actually tell and say, okay, if data is always 500, 500, 500, and all of a sudden you see 1 million, and then all of a sudden it comes back to 500, 500, 500, 500. So that tells you that there is something wrong with that chunk in 1 million. So joint distribution, which relates the informations and how they occur in space and in time, can actually help you understand what could be wrong and what could be right, but it has its own disadvantage. Disadvantage is that it's always judged by the person using it. So it's only the person that created the network that can actually work with it. Sometimes someone that doesn't create the network will have his own different opinion. So I didn't use Bayesian belief network. Another very powerful algorithm is principal component analysis, which some of you must have heard about it. It uses dimensionality reduction to, run classification. I'm running very fast because of time. So here we can't use, I didn't use this because it uses linear transformation to do its dimensionality reduction. So it's not very suited for me. What I'm looking for is something that could actually create a nonlinear dimensionality reduction. When I say dimensionality reduction, what I mean is a learning process for some artificial intelligence, some powerful artificial intelligence algorithm use dimensionality reduction to learn the structure of data, and then they give an output that tells you that it is good or it is bad. So here we used autoencoders and isolation forest to do our analysis, which you are going to see how we came up with that. So autoencoders are like this. They are neural network that are symmetrical. Input and output are symmetrical. Then we'll have a constraint space here that is called the latent space, which compresses data. This is where the actual learning takes place. And then here we use two autoencoders, neural network, to get the inputs, compress them, and then bring out the output. So what we are trying to do is that we are trying to generate an output from this autoencoder and compare the inputs to the outputs. Now, if it is we believe that if it deviates so much from the input, if the output from the autoencoders deviates so much from the input, then that means there is a problem. There is a problem with that data. So that is the idea we use here. So what we did is to generate error, a probability distribution, an error distribution of the results of this, of the predictions of these two artificial intelligence models. And then with this distribution in error, we could tell and say, we can put a limit and say, okay, if anything, maybe if I draw a line here, for example, with my mouse, anything above this is wrong data, anything below this is good data. Remember that the error, if it is much around this side, that means it's closer to zero, but it is high, that means it's far away from zero. So what we try to do is that we try to flag sensor information that have a high reconstruction error as the potential error. And then we use another algorithm called isolation forest to grade this error and tell which one we are more to grade. Like what we're going to use this model to do is to pass in this error into this model. So this model will identify data that are good and bad using its own way of classification. Okay. So this is so let me just quickly make comment about this slide. So this is how the autoencoder works. It tries as much as possible in the latent space to carry out dimensionality reduction and project all the data onto a manifold called a reconstruction manifold, which is a kind of curve that it creates on its own. Any data that doesn't fall, that is not orthogonal to this manifold, is flagged as an anomaly. So that is the principle. So if you look at any data, all these green data, they are not, all these data points that are green are not anomaly because they are at right angle to this manifold, they are orthogonal to this manifold. But if you look at this, they are not orthogonal. So when I say they are not orthogonal, they are not at 90 degrees to the manifold. And those ones are flagged as anomaly. That is how it works. And then we evaluated the model by looking at how it performed on the training and test set, okay? So these are the best way to evaluate model. You have to plot the loss function against epoch for the train and the validation loss, okay? And then when both of them are going down, are decreasing with epoch, it shows that the model is good. Especially when the validation loss is lower than the training loss, then it shows that the model is good. And also, we also validated the model by plotting the reconstructed manifold in the latent space and seeing how independent the reconstructed manifold are to each other. So it's actually an advanced model. So it's going to sound somehow a bit abstract here, but what the idea I'm trying to create here is that we evaluated this model using some major deep learning approach, which is not necessarily the mean square error kind of stuff we do. Okay, and then here we start plotting our results and then the original data. So if you look at this blue, all these blue points, these are the original data that are potential bad data, okay, bad sensor. So we see it here, you see all this information. So these are the sensor information, you see how bad they are. But if you look at the blue ones, are the ones that are presumably bad based on the model, because what we did was to match it with the artificial intelligence model. So the artificial intelligence model is the yellow line, the green and yellow line that we are seeing here. Sorry, the green and the maybe red, yeah, light red line, or the blue line is the original data. So here, artificial intelligence, the two model is following this trend and telling you that all this information here, I cannot capture it. So, but isolation forest made it a little bit more vivid for us. Here, we passed all the reconstruction error into the isolation forest, and it was able to make it clearer to us and put a score and say any data that has an uncertainty score threshold above or below 0.000458 is bad, and anything above this is good. Okay, so we use this to give a more black and white approach, and that gives us the ability to be able to identify it. And then we plotted it and say, okay, for bit depth, the red point is the wrong information, while the green is the right data. For hole depth, the same thing. So if you see red, it's anomaly. If you see green, is good. If you see red, anomaly, green is good. So we did this for rate of penetration. We did that for average surface tog and then all. So these are the results. And that brings us to the summary. So here we can see the ones that have higher uncertainty score and the ones that have lower uncertainty score. So the ones that have this shows how the uncertainty score are, or let me put it this way, this is the histogram of the uncertainty score. So I can supply this to a drilling engineer and tell the engineer that if you analyze your result and you have an uncertainty score higher than, for example, for bit depth, higher than maybe 5, if the uncertainty score is 5 times 10 raised per minus 5, then that data is wrong. So it has to be below anything, below this. These are okay, for example, all this has to be below 6 times 10 raised per minus 5 to be a good data, anything above it. So how? Pass in all my sensor information into my artificial intelligence model, generate the output and uncertainty score, and use that to tell if your sensor information is good or is bad. So make it very easy instead of using your single analysis. I think that brings me to the end of this slide. And at this point, I think I need to stop and ask for questions if there is any. Okay.
All right. Thank you very much, sir.
Sorry,
Thank you very much.
I know I told. Okay. Okay, go ahead. Sorry, can hear you.
No. It's fine.
Okay.
It's fine, sir. Yeah.
Yeah.
So that was a great one. That was so much about digitalization, but thank God, at least he has done justice to much of our case here. Thank you very much, sir. And if there's anything I would like us to take home is to remember that digitalization is a course that the world is taking now. And you have to find your way through one of them, through one of the opportunities that lies there. And our guest speaker today has done so much to explain to us how we can fit in. And one of it, of course, even from the polls we did, you can see that artificial intelligence and machine learning takes much of the precedence here.
Yeah.
Thank you very much. So we'll move on straight to the question and answer. If you have any question, I don't know, maybe you can just put it up in the chat box, if it's possible. If you have any question, you can put it up in the chat box. So this is an opportunity. If you have any question that relates to all that our guest speaker has done, and even if you have anything that is outside what he has done, but is related to our theme for today, of course, you are free to ask. Okay, so I'll be checking through the chat box for any question. Okay, I'm yet to see any question.
I'm sorry, not really a question, but more like a comment. Hi, James. Thank you. You've blown our mind off. And thank you for this wonderful presentation. I would suggest for students who want to go into the role of data science, especially undergraduates, what path do they need to follow? I think that would be a good one to be able to admonish us as students. Thank you. And you could also differentiate between data science from data analytics and data engineer. Thank you very much.
Okay, thank you. Very good question. Yeah, so yeah, that is an important question, and we keep seeing this question coming up everywhere. And let me start from this second part, of it, which is the data analytic, data science, and data engineer, because these three these three disciplines are already in the forefront of digitalization. And it also would really help any person that falls in any of this area would also help in participating in digitalization. Being part of it is very exciting. So data science generally is focused more on the algorithms that are used to generate products. So we do more of training and focus, kind of predictive analytics in data science. So here is where you need to understand the algorithms and how they work, how to use them, when to apply them. And it might end there. It might end at some people will tell you that data science shouldn't go too far into deployment, where you do a web deployment and you start doing software development for it. So, but what data science actually consumes is the code that drives the process, okay? And then the thinking that goes into the process. Because if I give you a problem to solve, you cannot just wake up and say, okay, let me use random forest. Why are you using random forest? Okay, let me use this. So some people just, and I see some people also try to use many algorithms to solve problem and compare. It's good, but sometimes you might not need to go into, trying to get huge, that kind of information. What you might need to do is to understand, is this problem a classification problem? Is it supervised? Is it unsupervised? When you identify the class of that problem, the next thing is to think through it. What process, what kind of algorithm is going to work? For example, in my own case, I limited my scope to algorithm that handles time series information and at the same time handles anomaly detection on time series data, okay? And also an algorithm that can handle anomaly detection by data compression and then learning through it. So that is why data science has to spend time understanding how these algorithms work. Data analytics, basically, you might not add in data analytics, you might not necessarily start using some of these sophisticated data science algorithm. You might just have to do most of the data analytics I've done, more or less, it's like clusters, trying to get information from clusters and interrelationships between informations, and then put them in a visual format. So data analytics actually consume more of the visual representation of data to individuals on a simple terms that they can understand, even to businesses. So you don't need to, do a lot of machining of it, but you have to do a lot of visualization for data analytics. It's also very important because you can get basic information from data analytics about, you can get basic insight about the data from data analytics before going into huge data science part of it. And fortunately, most data scientists are also somehow can be good data analytics engineers. For example, because of data pre-processing, it has made most data scientists to try as much as possible to understand some things from data. Then for data engineers, which is different, which is not really totally different, but it's a bit different. And data engineering will also assist in terms of preparing the data pipelines that will be used for engineering. One of the experience I had with data engineering is while I was working in my former company, we wanted to create a database, of our production information, so that it will be easier for someone to go into the database and fetch information that is already clean and clear. So I wasn't involved in the process of getting that database to place. What I'm involved in is give me database and I work from database. So those processes that got the database in place has to do with connecting it to an SQL server, Microsoft Azure, developing data pipeline and all that. Those upfront jobs, upfront activities before it gets to data science part is what the data engineers might handle so much. In fact, that's what they will be handling. They have special tools to handle that. So that is why today, because we don't have some good data architectures in place in some of the industries, some industries might want to have data engineer come in first to set up that structure, and then data scientists and data analytics engineers could also work. And then sometimes in an organizational setting, you see these three distinct discipline functions together as a team with software engineers part of it to help make the product more consumable at the end of the whole process. So that is what I could say about that. And then your first question, the first question was talking about, I forgot that. Can you come back again with the first part of the question?
No, we're good. Thank you very much.
Okay. Possibly I've touched it. Okay. Yeah, so this, as a question here that says, please, when is SPA drilling uncertainty prediction technical section taking place? Okay. Actually, this is a group in SPE. It's actually a group in SPE. Did I send the link? Let me send the link. It's actually a group in SPE, a subgroup in SPE. I'm sending the link to the group chat. So drilling engineers, yeah, just like a subgroup in SPE, I can come up with a group and say, oh, Society of Reservoir Engineers in SPE. So it's a group of engineers that have drilling interests. So they came up with this competition a little small. I don't know if it is yearly. I really don't know, because we saw the advert and we decided to give it a trial. Our intention when we are participating in this competition was not really to win. We were like, okay, let's use this competition as a means of actually learning. And it's helped. We did it for 6 months and were able to emerge. It was good. And we did something very good. So I sent the link there. You can look them up and follow them, their activities, and know when they are going to come up. And you should also participate in these competitions if they come up. What I want to also say is, yes, sometimes you feel that you are far off, you're still far off in your data science knowledge. But I actually saw, for me, because I started doing data science, in a different way in past. Actually started doing more of it from 2017 to 2018. But in the past, we have a way we were doing it, where you do your regression, and we did part of neural network, but not even call it data science. So we found out that majority of the knowledge about data science actually comes from understanding how to deal with a problem, not actually the code. Okay, not actually the Python code. Python code is very important, and they are repetitive, because sometimes when you have the code structure is similar. If you're using TensorFlow, if you're using all these things, you see, they have kind of similar code structure that you can easily put in place and run your model. But being able to think through how you're going to solve the problem from scratch is what really matters. Okay. So that is all I have to say for now. If you have any other question, you can.
Fantastic. Thank you very much.
Okay. So if you have any question, also, if you don't have any specific question here, I'm free. You can contact me. I sent my email address, and then you can also contact me on. You can also contact me on LinkedIn for your data science challenges or anything further from now.
Okay, in the absence of any question now, and I think we've lost Abednego due to technical difficulties,
Yeah.
I think, the network. Yeah. So, any other question? I think, as you have stated, if there's any other question, you can message him in his email address or LinkedIn, contact him via those platforms.
Sure.
Well, so on behalf of the SPETBU chapter, we sincerely appreciate your presence, your time, and the lecture you delivered today. We surely have learned a lot. And thank you very much, sir. Well, with this, I think we have come to the end of today's program. And I would like to end this note with, thank you very much. May God bless you, sir.
Thank you. Thank you all for coming. Feel free to reach me anytime. And
All right,
have a good day.
Thank you very much. Okay, I will now end the meeting. And thank you, everyone, for attending.
Is the meeting over? Oh, guys, is the meeting over? Burate?
Meeting ya kare ba.
Okay, haba haka one time babu wani wannan?
Hey, yanzu
Just
kake
like
shigowa ko?
Na'am?
Oga Alamin. Yanzu ka shigowa sai sa. Presido.
Musa?
Presido ya aka.
Presido ya wuce.
Haba ya wuce? Tun fu aka fara.
Ai duk inda aka shiga an 400 level dole sai kun nuna kanku.
Me ne faru? Ina me faru?
Na san sai kun nuna kanku duk inda aka shiga.
Ka bar munafurci ka zo? Ne kuma aka yi.
Ba gashi ba kowa sun fita sai kowa.
Kai. Ke ma daga kanan.
Kai kana mai baji. Na ji buri a sallallahu alaihi wasallam.
Dino.
Ruri ka wanda na gan ka wannan ka kunna video.
Foto Rudi, a cikin magaga wata shi ya fi dariya wallahi.
Wane ne?
Dino Rudiga.
Oh, Rudiga?
Yana tafiya ba wai ana abu serious yana tafiya yana wannan numbi.
Asabiya kana ina ne?
Allah yana boci buratai.
Kana da wasa?
Muna ruwasa. Lafiya ruwasa muna zuwa mai hira kawai mu dawo.
Ba gwanda kowa ina wanda yake aiki a National Assembly fa.
Kai buratai wannan.
Ka bari.
Wallahi ba ta kai da iska ne.
wallahi
gaske na ji sun bude kuma
wallahi ina samun
kai bari ni ma gudu
to ba damuwa ni ma barin ware
to a sata za sai mun hade
ai wala ta yawa ya jima